Yeah, it's been a while. I think it's about time I made another video. Welcome to Cool Dude Clem's Electronic Workshop with me, your host, Cool Dude Clem. So yes, you're looking at another Tesla coil, or another work-in-progress Tesla coil. I haven't tested this one out yet, but here's the circuit, if the camera would just focus on it. And that's what I've built right here. Although I've had to make a few changes, but we'll go over those in just a moment. I just want to go over all the parts in the circuit. So to power the primary, I've got this big mother fudger of a transformer right here. Also, I tried this transformer on the other Tesla coil, the PLL Tesla coil, and it gave me much better output because this one is able to provide the 50 volts at whatever current it was pulling, whereas that other transformer just simply wasn't capable of doing that. And I tried to record that, and well, this is what happened. You can sort of see how well it worked, but the camera kind of just keeps freaking out every time I turn the thing on. But anyway, yeah, got a couple of MUR something or other diodes as my rectifier, a couple of capacitors to smooth out the thing, and also suppress RF getting back into the power supply. Using the same coil as before, so same primary, same secondary. And in this little box here is the control circuitry with a 555 timer and a UCC 37322 gate driver. So because I don't have all the same parts that are listed here, I've had to improvise, but I think it's still going to work. I don't have an IRFP 460 MOSFET, but I think an IRFP 640 is going to work just fine there. Instead of a LM7812 regulator, I'm just going to use my regulator power supply to power this part of the circuit. I don't have any 1N60 diodes, so I've used 1N148s. I think they should work just as good. And finally, I don't have a TCC4220, so I've used a UCC 37322 instead. There's really not much difference in the two chips. Pinouts are exactly the same, they do the same thing. The only difference is that the TCC420 doesn't have, pin 3 doesn't go to anything, but on the UCC 37322 it's used to enable the chip, but that's internally pulled high anyway, so I think I can just leave that pin disconnected, which is what I've done. Now I'm not sure what this 555 timer actually does. At first I thought that was some kind of interrupter, but I don't think it is now. What I think that does, of course I could be wrong, I think that basically starts the oscillation going, you know, starts the thing oscillating, and then the feedback from the antenna takes over and it oscillates at whatever the self-resonant frequency of the secondary is. And of course the other thing, I don't have the same coils specified in the schematic, but I don't think that's really going to be much trouble. Anyway, I've got to wrap this thing in foil now because in the past, I've had a lot of parts die on me in the solid-state Tesla coil circuits, and I think that's mainly due to an overdose of RF. I mean, I've had chips fail on me, I've had a 555 go up in smoke, and things like that, so I'm going to be extra careful this time. I've also taken extra care regarding the grounding. Now I'm using my oscilloscope as the central ground because that's connected to the plug, which is connected to ground. Which means this part here is connected to ground, so the secondary's ground goes along a wire to this point here. The primary's power supply ground also goes along a separate wire and ends up there. So that's a much better idea than, say, connecting all the grounds here and then running that off to the ground, because that could cause problems. And I've even made it so this thing has a separate ground. So right at the output side of the circuit, here's the ground wire going along to the MOSFETs. And of course we've got another wire coming off the MOSFETs going to the primary's power supply ground. Well, enough waffle, let's turn this thing on and see if it works. Okay, so here I am about to test the thing. I'm having to record all new narration here because the stupid me didn't have the microphone switched on. So you couldn't hear anything I was saying, but that's probably a good thing. Anyway, it's a good thing I double checked my wiring because I'd accidentally connected this ground wire to the positive rail instead of the negative. And that would have been a disaster if I turned it on. Just completely shorted out my power supply. Anyway, let's try this and see if it does anything. Running this ballasted, of course, so I can run it on low power, then ramp it up. So let's see what we get. And we got smoke from my fuse, so that's not good. Well, debugging time, I think. We have had a casualty already. Nothing major. But it's really smoked this 10 ohm resistor here, this resistor here, but surprisingly that's still within tolerance. And this circuit still appears to be working. It took a licking and it kept on ticking. So the only thing that got hot was that resistor. Both the chips seem to have survived. Mind you, the data sheet for this chip says it can handle 9 amps. I think that's a little optimistic, maybe 1 amp. Also, you might be wondering what these 3 capacitors are for. Well, that's because the UCC chips, you've got to decouple them properly. If you don't, you get a very hot chip. And at the moment, that's stone cold. There's no heat coming off that whatsoever. Yeah? And it survived, which is the important thing. The MOSFET, on the other hand, is a complete write-off. It's disconnected from the circuit right now, even though you can still see the wires attached to it, but it's a complete dead short from here to here to here, and of course, here to here. So what the bloody hell did that then? Okay, so now we know what happened. The MOSFET died. So this is attempt number 2. Now, I've just swapped out that transformer for this one here, which doesn't provide as much voltage, but I think this will be good for a low power test. And I've also changed the MOSFET to an IRFP260. I've got to be careful because the thermal grease I use to attach it to the heatsink is conductive, so I've got to keep that in mind. Make sure that's not okay. That looks good. It's not touching anything. So let's see if this one works. So this little circuit here is on. Nothing is smoking. That's good. Okay. I'm going to turn on the other transformer now. And nothing. Well, no luck yet. I've tried several different things. Moving this antenna closer. Flipping the primary around. Well, we're not getting much yet, but we are getting oscillation, so that's a good thing. If I turn this on, and I've also got this meter measuring the amount of current that this circuit here is taking, so that's the gate driver circuit if you remember, and that will also blow the meter's fuse if the MOSFET shorts out again, so we're not going to have any damaged components, just one fuse to replace, and that's really no big deal at all. So let's see what we get this time. Nothing. It's not even doing anything now. Because maybe being the idiot I am, I turned the safety on and then forgot to turn it off again. But it is oscillating, as the fluorescent tube tells us. Now, mostly macros. I know you're probably watching this video, and I was going to build the RF detection circuit. Unfortunately, I thought I had a spare swing needle meter left, and I don't, so I'll have to salvage one of those out of something, and I'll use that in my next Tesla coil video. Anyway, the only other thing I can think of is ramping the voltage up a bit, because maybe it's just not producing enough to get that main oscillation going, so I'm going to try it with this transformer here, and if that one doesn't work, I'm just going to give up on this one and move on to another one. 741 million times the charm, hopefully. So let's see if it works now. Oh yes, safety. pants. Well, I done all I can do, and this circuit just clearly does not work. Well, it does seem to be operating at the right frequency, so it's obviously picking up from the antenna when I turn this on. Got 1.2 megahertz showing up on the meter's frequency counter, but no breakout. So yep, this circuit is a total fail. But like I said, I'm not giving up on building a good solid-state Tesla coil. No way, I've got one more solid-state Tesla coil that I'm going to make, and I think this one is going to blow everything else I've built away.
Okay, so this is my new Tesla coil design.
Look at it! Alright, I'll stop being retarded now. So the new Tesla coil is going to be based on this circuit here, which I found on the internet, and I've seen this Tesla coil running, and it works pretty good. That's not to say that my version is going to work very well, but we'll see. So there's going to be an upcoming series of videos on building that particular Tesla coil, building it up piece by piece, seeing how well each bit works, and then putting it together. And I should have a pretty good Tesla coil. And that'll be the last Tesla coil project for a while, because after that I'm going to be working on a tube FM radio receiver. So until then, and until next time, goodbye.